Find the exact value of the trigonometric function sine 5 pi thirds. So we essentially need to do two things. One is reference angle and two is quadrant. So this can all be done by knowing where the pi thirds are. 0, 1, 2, 3, 4, 5 pi thirds. There we go. That is 5 pi thirds. The reference angle is the closest x-axis. That would be pi thirds. Reference angle is always between 0 and 90 degrees, or 0 and pi halves, so it is positive. Even though here we're marking it counterclockwise, it's still the reference angle is always positive. We also see that we're in quadrant 4. Now all students take calculus tells us that quadrant 4 only cosine is positive. We're dealing with sine, so we know our answer is going to be negative. So our answer is negative. That comes from the quadrant. And what is sine of the reference angle pi thirds? Well, it's square root of 3 over 2. That completes this problem. Find the value of cosine of negative 5 pi fourths without a calculator. So starting off with where this is, it's nice to know where the pi fourths are. So 0, negative 1, negative 2, negative 3, negative 4, negative 5. This is negative 5 pi fourths. The reference angle would just be pi fourths. And the quadrant, we're in quadrant 2. And all students take calculus, tells us that sine will be positive in quadrant 2. We're dealing with cosine, so our answer will be negative. Our answer will be negative. And what is cosine of pi fourths? It's square root of 2 over 2. And that completes this problem. So finding sine, cosine, any of the 6 trig functions of a recognizable angle, one on the unit circle, either equivalent to 0, 30, 45, 60, or 90 degrees, is a two-step process. Step 1, what's the reference angle? If we found the reference angle to be pi fourths, that got us that cosine is square root of 2 over 2. The second part is what quadrant. Once we found it was in quadrant 2, that tells us the only sine is positive, so our cosine is negative. Tangent of negative 2 pi thirds. First off, 0, negative 1, negative 2, this is negative 2 pi thirds. The reference angle is something we need. The reference angle would be pi thirds. And the quadrant, we're in quadrant 3 here, where all students take calculus, tells us that tangent will be positive in quadrant 3, and we have a tangent, so our answer is going to be positive. And now, what is tangent of the reference angle pi thirds? Tangent of pi thirds is square root of 3. Oops, there we go. And that completes this problem. If you want a way to think of what is tangent of pi thirds, you can think in terms of sine over cosine. Sine of pi thirds is square root of 3 over 2, so that puts a square root of 3 in the numerator. Cosine is 1 half with a 1 in the denominator. That would give me square root of 3 over 1 for tangent. Secant 3 pi fourths. So first off, let's think about where 3 pi fourths is. 0 pi fourths, 1, 2, 3. Here is 3 pi fourths. The reference angle for that is pi fourths. And we're in quadrant 2, where all students take calculus. Sine is the positive one. Sine and its reciprocal cosecant will be positive there. In this case, we're dealing with secant, so that would go with cosine. Cosine's negative in quadrant 2, so our answer is negative. But what is secant 3 pi fourths? Well, you'd think cosine of the reference angle. Cosine So you'd want to think cosine of pi fourths. And that is either square root of 2 over 2 or 1 over square root of 2. Those are both well-known values for cosine and sine of pi fourths. Now, the secant is the reciprocal. So which one of these would be easier to flip? And the answer is the 1 over square root of 2. If we do that's reciprocal, we just get square root of 2. And that completes this problem. So when you're doing secant, think cosine. 3 pi fourths, you have to get the reference angle and the quadrant to know what sign and value you have, and then flip it for secant. Great. Find cosecant 4 pi thirds without a calculator. First off, 4 pi thirds. Pi thirds would be 0, 1 pi third, 2 pi third, 3 pi thirds, 4 pi thirds. So this is our angle, 4 pi thirds. The reference angle would be pi thirds. And we're in quadrant 3, where all students take calculus. Tangent is the positive one, and its reciprocal cotangent. We're doing cosecant, which is the reciprocal of sine. Sine is negative in quadrant 3, so we know our answer is negative. But we're doing cosecant, so we would want to think in cosecant, we want to think sine, and we want to think sine of the reference angle, pi thirds. Well, that's square root of 3 over 2. So cosecant, we already determined it's negative. Cosecant is going to be the reciprocal of this, which will be 2 over square root of 3. Many instructors and even books nowadays will accept this answer. This book likes to rationalize the denominator, so we would continue by multiplying by square root of 3, square root of 3, get a little more space. And that would give us our final answer of negative 2 square root of 3 on top and 3 on the bottom. And that completes this problem. Find cotangent negative 11 pi sixths without the use of a calculator. We will use reference angles and quadrants. Let's first find out where 11 pi sixths is. Negative 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. This is negative 11 pi sixths. The reference angle would be pi sixths. And we're in quadrant 1, where all of them are positive. So our answer will be positive. No question about that. Positive. Now, cotangent of pi sixths is the square root of 3. That completes this problem. If you want to have a nice way to get cotangent, and you know the sine and cosine well, cotangent is cosine over sine. For the reference angle of pi sixths, cosine would be square root of 3 over 2. Sine would be 1 over 2. The 2's cancel. You get square root of 3 over 1. That's square root of 3. Find the coordinates of the point pi thirds comma negative 5 after it is moved pi thirds units to the left. What is critical about understanding transformations, in this case a horizontal translation, is when you move to the left, you are subtracting pi thirds from the x value. Why the x value? Well, left and right is the x direction. Left would be negative, so we really want to just subtract pi thirds from the x value. And that would give us 0. But nothing happens to the y value because we haven't moved up or down. And that completes this problem. Find the coordinates of the point pi comma negative 8 after it is moved pi sixth units to the right and moved 1 unit upward. So taking pi comma negative 8. Moving pi sixths unit to the right, you would add pi sixths to the x value, because right is the x. And 1 unit upward, we would add 1 to the y value, because up and down is in the y direction. Adding all that together gives us pi plus pi sixths. That would be 7 pi sixths. I'll leave the fraction work to you. And negative 8 plus 1 is negative 7. And that's it. We've translated this point. Determine the midpoint that lies between the two given points, 8 pi comma 1 and 4 pi comma 9. The midpoint is a formula. Midpoint formula is given as a point, and it's x1 plus x2 divided by 2, comma y1 plus y2 divided by 2. What this formula is no more than adding two things up and dividing by 2 is an average. So they're averaging the x values, and then comma, they're averaging the y values. So the midpoint is no more than average. This might be a nice way for you to remember what midpoint is, average. Okay, so we need to take the x values, 8 pi plus 4 pi, and divide that by 2, comma, and the y values, 1 plus 9, and divide that by 2. And that gives me 12 pi divided by 2 is 6 pi, and 9 plus 1, 10 divided by 2 is 5. And we have found our midpoint. That completes this problem. Determine the coordinates of the specified point T. So first off, here is T. The coordinates of a point are given by x, comma y. Now the x value, I'm not sure about. Let's take a look. This is pi here, and we've divided it into 1, 2, 3, 4, 5, 6 parts. Again, 1, 2, 3, 4, 5, 6 parts. So that means that each one of these is a pi sixth. So that is pi sixth. 2 pi sixths, 3 pi sixths, that is 4 pi sixths, which reduces to 2 pi thirds. That's our x value. The y value, it's on the x-axis, so y equals 0. And that would be how you find the coordinates of this point. Graph the function over a 1-period interval. Y equals 4 sine, parenthesis, x minus pi, parenthesis, plus 4. So sine is usually centered around the x-axis. So the x-axis is kind of like this, the average value, the y value of the sine. So in this case, the plus 4 actually puts us up where the center of this will be at 4. The amplitude of 4 means that this graph is going to go from the center of 4 up 4 and down 4. So this graph is going to alternate between these two red lines. Now we just have to figure out how far it alternates, how fast it alternates, etc. The period of the sine wave is usually 2 pi. If there is a coefficient of the x, you divide by that. But in this case we don't, so the period is 2 pi. The minus pi, there we go. The minus pi tells me we're moving to the right pi. Normally the sine wave would start at the center of the alternation and go up. In this case it's going to start at 4, but we're to the right pi, so we're going to start right here. So our first dot is here. Now a period of pi would put us at 3 pi. We're going to extend our number line a little bit. After a period of pi, the sine wave is back to the center. And sine hits its center line in the middle as well. In the middle of pi and 3 pi would be 2 pi. In the middle of those, the sine wave will get to its amplitude. It'll go up first unless there's a negative in front of this 4. So this is up and then down. So we're going to get up to 8 and down to 0. And now you just try to make a nice smooth curve through there, and we have graphed this function over a 1-period interval. There is another approach using the 5 key points that I would like to cover next. First off, you need to know the key points of the regular sign. So for y equals sine x, the key points would be 0, 0, pi halves 1, pi 0, 3 pi halves negative 1, and 2 pi 0. So it will start at 0, 0, pi halves 1, pi 0, 3 pi halves negative 1, 2 pi 0. So that's the regular look to a sine. What this function has done is to the x value we're going to add pi. Plus pi to all the x values. The y value, a couple things happen. We have a plus 4 and we have a times 4. So the y value has a plus and a times. The multiplication always comes first when you do this. So we're going to multiply by 4, then add 4. So we're going to multiply by 4, then add 4 to the y's. Multiply by 4, then add 4. Multiply by 4, then add 4. Multiply by 4, then add 4. Oops, I didn't get the add 4. There we go. Add 4. And finally multiply by 4, and then add 4. So our final answers will be these key points. Starting at 0, we added pi, and we just get pi. Starting at 0, multiplying by 4 is still 0, then plus 4, we get 4. Comma. Next point, pi halves plus pi, 3 pi halves. 1 times 4 is 4, plus 4 is 8. Pi plus pi, 2 pi. 0 times 4 is 0, plus 4 is 4. 3 pi halves plus pi, 5 pi halves. Negative 1 times 4 is negative 4, plus 4 is 0. And 2 pi plus pi is 3 pi. Oh, sorry, I'm running out of room. My writing's getting bad. Let's try that again. 3 pi. And 0 times 4 is 0, plus 4 is 4. Now what these points are exactly pi comma 4, 3 pi halves comma 8, 2 pi comma 4, 5 pi halves comma 0, and 3 pi comma 4. That is a different approach to being able to graph these functions. It's a great way to go, and I to have more than one method to graph, so that if one causes trouble you can fall back on another, or you can use the second approach to verify your answer to make sure you got it right. Determine the equation of the function that is graphed. So we have a graph. It's a typical sine or cosine, back and forth, up and down. This graph has a center right on the x-axis, and from the x-axis it goes up to and down to, over and over. That would be an amplitude of 2. So I'm going to start out by saying y equals 2. And next up is it a sine or a cosine? Normally sine will start at the origin and go up. This one starts up and goes down towards the center. That's what a cosine does. A cosine starts at its amplitude. So we're going to use a cosine for this. Cosine. The period is normally 2 pi. So from the very top to the top of the next bump is 2 pi. So this is a regular period. So we just have x. It normally starts at 0 up at the amplitude. That's where this one is starting. So we're not doing a plus or minus x. We're not moving left or right. So we have 2 cosine x. And last, is it up or down? And it is not, because its center, where it oscillates up and down from, is at 0. So we don't have a plus 0. So y equals 2 cosine x is the easiest model for this equation. You could also use a sine, and you'd have to shift it left and right, but this is by far the easiest one to do.